Hi everyone! So for this problem we will be drawing a normal probability plot, and a normal probability plot is a graph that plots observed data values versus normal scores. And a normal score is the expected z-score of the data value. So for this problem, the directions state the data in the table below is the number in minutes that 5 individuals spent in the drive-thru at PJ's Coffee Shop in Hammond. Is there evidence to support the belief that the variable of waiting time is normally distributed? So our first step when computing problems like this is to arrange data values in ascending order. So that means from smallest to largest. Luckily, in this specific problem, our values are already in ascending order for us. So we have 3, 3.3, 4.8, 5.9, and 7.8. So our second step is to compute our Fi, which is the expected area under the normal curve to the left of the observation. So we have a formula for calculating that, and the formula is Fi equals I, which is your index or the position of data values in the order to list, minus 0.375 divided by n, which is your total number of observations, in this case it's 5, plus 0.25. So we've got to calculate that for each observation that we have. So for the first one, it'll be 1 minus 0.375 divided by 5 plus 0.25. The second one will be 2 minus 0.375 divided by 5 plus 0.25, and so on. So you can plug these values into your calculator, plug the equation into your calculator, and you're going to round to your 10th for this problem. So our first one is going to be 0.1, our second one is going to be 0.3, our third one is 0.5, our fourth one is 0.7, and our fifth one is 0.9. So now we have our Fi, which is the area under the normal curve. Well, this expected area under the normal curve. So now that we have these values, we can go look in our chart, which is table 5, and we can look for each of these values. So, since this is the area, we need to find our expected z-score. So the area will be in the middle of the chart and the z-scores are on the outside. So for the first one, we're looking for the number that is closest to 0.1. So let's look and see. And the closest number to 0.1 is 0.1003. So the z-score that corresponds with that area is negative 1.28. So now let's look for 0.3. Right about here. Okay, so the closest area that corresponds to 0.3 would be would be 0.3015, and that z-score would be negative 0.52. So now we're looking for 0.5, which is actually 0.0 exactly. And then we're going to look for 0.7. Yep, so the closest one to 0.7 is 0.6985, which has a z-score of 0.5 0.2, and the closest to 0.9 would be 0.8997 with a z-score of 1.28. So now we have our expected z-scores, our observed values for each of these observed values. So now that we've found our expected z-scores, we can plot them on a graph. So our x-axis are going to be our actual observations, which are our horizontal axis. So this side will be observations, and this side will be our expected z-score, which is our y-axis or our vertical axis. So now we're going to plot these points from what we found. So we have 3 and a z-score of negative 2.8. So we're going to go right here is about 3 and negative 1.28 is going to be right about here. And then our next one is 3.3 with a z-score of negative 5.2. So that'll be right about there. And then 4.8 with a z-score of 0.0, which will be right about there. And then 5.9 with an expected z-score of 0.52, right about there. And then an observed value of 7.8 and a expected z-score of 1.28, which will be right about there. So that's how you plot your points. So now that we've plotted our points on the chart and determined that it looks like it's approximately normal, we need to find our correlation coefficient to compare it to our critical value to determine if it is in fact approximately normal. So our correlation coefficient is a measure of the strength and direction of the linear relation between two quantitative variables. And this is from section 4.1. So if you need a little refresher course on correlation coefficient, that's where I would look. And we're going to do it in our calculator, even though you can do it by hand, just to save us some time. So you're going to go to Stat, Edit, and you're going to type your observed values into L1 and your response or expected z-score, which is your response variable, into L2. And then you're going to do Stat, Calc, and then you're going to go all the way down to number 4, which is the equation for the least squares regression line. You're going to hit Enter, and then you're going to get your R. So for this case, R equals 0.9461. So that's our correlation coefficient. So now we need to find our critical value to compare the two. So you're going to go to table 6 in the back of your book, and you're going to look at it right here, and you're going to do it based on your sample size. So for this problem, our sample size is 5. So our critical value is 0.880. Okay, now that we found those two values, we need to compare them. So you're going to compare your correlation coefficient to the critical value. So 0.9461 to 0.880. So your your correlation coefficient is greater than your critical value. So we can determine that the data is approximately normally distributed.